Hello, so I wanted to take a few minutes just to work through this calculation with you, give you an example of exactly how to solve this type of question. You will have a couple of these questions on your lab exam that you will be working through. And there's also some practice questions in a worksheet that's attached to the lab as well. So you'll have plenty of practice with this, but I kind of wanted to give you an opportunity to actually see one of these problems worked out with some true numbers here. So let's go ahead and let's look at this. As I described in Canvas, our first step here is to calculate out the approximate number of red blood cells that would have been in the original sample of blood that was being tested within the hemocytometer. And so let's kind of come in here. So we are going to plug into this box or this line right here the averaged number of cells that you would have calculated by calculating out those 5 squares. Remember, each of those squares on the hemocytometer has a total volume of 0.004 millimeters cubed, and we got that by multiplying the length, the width, and the height of the space by which those red blood cells occupied. And so for our example, we're going to say that there was 110 red blood cells per 0.004 millimeters cubed in our sample when we averaged that together. And we're going to multiply that by 200 because remember, this is the value by which we diluted the original sample. And so now, in order to come back to the approximated original, we have to remultiply this. So 110 red blood cells per 0.004 millimeters cubed times 200, which represents the dilution, equals 22,000 red blood cells per 0.004 millimeters cubed of blood. All right. Now, if you recall from reading through that handout that I gave you guys access to, our red blood cell count, our total red blood cell count, is not measured in 0.004 millimeters cubed. It's measured in per millimeter cubed. Right, so 1 millimeter cubed, which means that we need to go ahead and transform our number into millimeters cubed. So how do we do that? Well, we set up this fancy little equation right here. And so we take that number from step 1, which was 22,000 red blood cells per 0.004 millimeters cubed, and we want to know how many red blood cells, X red blood cells, does this side of the equation equal per 1 millimeter cubed. So how do we do that? Well, we cross multiply. Right, this is first, and so when we multiply 0.004 millimeters cubed times x to the RBC, all right, by the way, RBC, what we end up getting is 0.004 x RBC per millimeter cubed. All right. Now, because this is what we're looking for convenience sake, we can go ahead and leave that off, and here's why. I'll give you a little bit of an insight here into why. because what this is going to equal is, if we multiply it the other way, 22,000 RBC divided by 1 millimeter cubed. It's the same thing. This and this is the same thing. So we can ignore that right now. So if we rewrite this ignoring the RBC per millimeter cubed, then what we end up having is 0.04x equals 22,000. All right. And so how do we go ahead and solve for x? Well, we're going to divide, because remember this is technically over 1. We're going to go ahead and we're going to divide each side. And so in our next line of our equation, what we're going to have is x equals 22,000 divided by 0.004. And when we divide 22,000 by 0.004, we come to find that x equals, let me write this out and then we can go in, and x equals 5,500,000 RBCs per millimeter cubed. Now, this is a little bit of a ugly number to deal with. So what we're going to do is we're going to put this into scientific notation. And so to do that, remember we simply count backwards from where the decimal point currently is, which is right here. So we're going to move this decimal point 1, 2, 3, 4, 5. We're going to move that decimal point 6 places. And what does that look like when we write this out based on scientific notation? It then looks like x equals 5.5 times 10 to the 6th RBCs per millimeter cubed. And that is how we solve for our total red blood cell counts.